Hello, everybody, and welcome back to today's episode of Understanding Your Economic Engine. Today, we're going to talk about product profitability. This blog comes in two parts, part A, which we're going to do right now, and part B, which answers the question that's posed at the end of part A. And so let's get right into it. We've always started these blogs with a little bit about your reticular activating system. This is the part of your brain that basically filters what you experience, what you see, and what you hear. It determines how you notice, or what you pay attention to, and how you view your world. And it puts a set of blinders on you. It limits your perspective. And the premise of these vlogs has been that your understanding and use of cost accounting in making manufacturing decisions might just be putting some blinders on you. And so today we're going to test that premise. We're going to work a little bit of problem. And this problem has to do with our factory. Our factory is a very simple place. It has two products. It has peas, which it makes and sells for $90. And the demand for this product is absolutely known. There's a demand for 100 peas every week. Similarly, we know the demand for cues, which we can sell for $100. There's demand out there to handle exactly 50. Can't handle any more. So if you make more peas or more cues, they'll just sit in inventory. So our factory makes peas and cues, and it makes it using three processing centers, A, B, and C, and one assembly place, part D, or section D. Each of these parts of our little factory have a single person that work in it. Their skills are associated with the department they work in. They are not interchangeable. You can't take capacity from A or skills from A and apply them to B or C, or vice versa. Same thing with D. All right, in order to make parts, P's and Q's, we buy one part, which is part W, and W's cost us $5. We also have three materials we bring in, X, Y, and Z, and each material costs us $20 per unit. To make peas, it's a fairly simple process. We buy 1 unit of X for $20 and process it through processing station A for 15 minutes. It then gets passed to C for 10 minutes, where it waits until the unit of material Y, which also costs $20, is processed at B for 15 minutes, then C for 5 minutes, and finally, those two components arrive at D and are assembled with part W, and a P pops out of your factory. And as soon as it pops out, you can get $90 for it. And again, you can make up to 100 Ps. To make Qs, the Y component is the same thing. We buy it for $20, process it for 15 minutes at B and 5 minutes for C. We add to that a unit of Z materials for $20 that gets processed in A for 10 minutes, B for 15 minutes. The assembly only takes 5 minutes because you'll notice there is no part W. Qs, again, sell for $100, and there's a demand for just 50 of them. All right, so here's our factory. It operates exactly 240 minutes per week, and it costs $6,000 for that week to run and staff our factory. Now, a couple little more things you should know about this factory. There are no delays, there are no losses. They have 100% uptime, no transfer time, no changeover time. This is as simple a factory as it gets. The instant raw material X shows up, it can get processed into A. It takes exactly 15 minutes. It's instantaneously transferred to C, where it takes exactly 10 minutes to process. And then it's instantaneously available for D. So there's no delays, no losses, no variability in this plant. This is about as simple a factory problem as you can work. And so what's the question? Well, how much money can our factory make per week? All right, how much money can this factory make per week? And they can only sell 100 Ps and 50 Qs. All right, to maximize your learning, work the problem before you watch part B. Have fun. Get help if you need it. but have fun. Work the problem.